Today we will discuss intermittent fasting, its different types, and how to implement a specific method of intermittent fasting to accomplish specific health objectives. Being aware of your goals will aid you in selecting the intermittent fasting style that is most suitable for you and aligns with your unique preferences and requirements. So, we have three main types of intermittent fasting. The first thing is what we actually call interval fasting, but in English it sounds like time-restricted feeding, that is, limited in time nutrition. This is a well-known technique for all of us, 8 to 16 or 6-18 or 4-20. When we have a feeding window during which we can eat to our heart's content, but once the clock indicates that the window is finished, we transition to hunger mode. So you can have nothing, you can only consume water, tea, coffee, and of course you must refrain from adding any sugar. The next type is known as intermittent fasting. It involves a 2-to-5 system, where you fast for 2 days a week and eat normally for the remaining 5 days. You can choose to fast for 2 consecutive days and then have a healthy diet for the rest of the week, or you can spread the fasting days throughout the week, such as on Monday and Friday. The choice is up to you. Well, there is also another modification. It is fasting every other day. So if you eat on Monday, then on Wednesday, then on Friday, and accordingly on Tuesday, Thursday, and Saturday you are hungry. All this applies specifically to intermittent fasting. And finally, a diet that mimics fasting. It replicates long-term fasting and is devoid of side effects that are intrinsic to extended fasting, which may be unfavorable for individuals with immunodeficiency, weakened individuals, individuals with advanced stages of cancer or kidney, or heart, or any other deficiency. This diet plan consists of a 5-day period with a very low-calorie diet, while ensuring the retention of all necessary minerals and vitamins through the use of multivitamins. And then, the remaining 25 or however many days there are in the month, the person again eats healthily. Technically, day 1 implies 1090 QOL with 10% protein, 56% fat, and 34% carbs, and from day 2 to day 5, 750 QOL with 9% protein, 44% fat, and 47% carbs. I will provide a link to Google Meet and you will download the recipes from there. The issue is, it is rather challenging to locate dishes that would fulfill these criteria because there are calculators that compute the quantity of calories, proteins, fats, carbohydrates in an individual dish, but to perform the opposite process, to choose a menu specifically based on the composition of proteins, fats, and carbohydrates that can be consumed, is such a formidable task. Let's proceed to the various types of intermittent fasting. Despite the fact that they are quite different in their methods, they still have 3 common features in common. This is autophagy, this is enhancement of mitochondrial function, and this is enhancement of the microorganisms in the intestines. Autophagy is the process of cleansing our cells by removing different accumulated metabolites, faulty proteins, residues of viruses, bacteria, and other unnecessary substances that are not needed by the cell. This process can be compared in such a way that when our cells work, waste gradually accumulates in them, which needs to be somehow removed, like, for instance, periodically washing the pan on which you fry something. If you do not wash it, it will be covered with a thick layer of soot and, as a result, the dishes that are cooked on it will become harmful to health and pose a potential risk. The same thing happens with the cell. If autophagy is absent or not functioning properly in a cell, it leads to the accumulation of various harmful substances that can cause DNA damage, impaired cell function, and various diseases can result from this, which can manifest either in neurodegenerative diseases, or in cancer, or in heart or kidney failure, and so on. And thus, cells possess a mechanism known as autophagy. And autophagy is a deeply conserved biological mechanism that exists from single-celled organisms to higher organisms like humans. Despite the presence of haters who will contact me about Osumi and Osinori's work, it is a fact that when he conducted his job, he specifically studied yeast fungi and the phenomenon of autophagy in that location. The fact is that this phenomenon exists among people, of course. Just yeast fungi were chosen as a very good affordable model that is easy to observe. Because how can you observe a living person in such a manner? You cannot slice it on a microtome and place it under a microscope to examine what is occurring in its cells. Yeast mushrooms serve as a highly valuable model. In addition to autophagy, of course, there are favorable changes that occur in the microflora of the intestines. I already have a video about the fact that we have two major groups of bacteria, firmicutes and bacteroids. And the imbalance in the populations of these bacteria results in different types of diseases. Typically, when firmicutes are not present and bacteroids rise, this occurs specifically due to the dominance of the Western diet, which is favored by the local population. Pasta, potato dishes with meat patties and different types of mayonnaise, potato chips, hamburgers, all washed down with beer. This is what is referred to as the Western diet, which leads to a disruption of our microflora. And accordingly, the microflora also greatly affects our health because it regulates inflammation, regulates the immune response, regulates our immunity, and even regulates how we remember, that is the ability to think, your intelligence even, and your psyche, your mood. In summary, the bacterial intestinal microflora is a complete organ that also requires maintenance in order to function properly. And here is intermittent fasting, irrespective of the type you employ. It normalizes the functioning of this vital organ. And finally, of course, there is an improvement in the function of mitochondria under the influence of intermittent fasting. Understandable, because when a person is hungry, it's always a calorie deficit. And since there's a deficit, alternative energy pathways are activated. Mitochondria, the powerhouses of the cell, are responsible for generating ATP, the energy currency of the cell. And correspondingly, the greater the flexibility of a person's metabolism, if they are able to utilize carbohydrates at one point, fats at another point, and perhaps even amino acids, there are what are known as glucogenic amino acids that participate in the synthesis of gluconeogenesis, for example, and also amino acids that directly participate in the functioning of the mitochondria. This is called metabolic flexibility. And accordingly, the more flexible the metabolism of a person, the more adapted he is to sometimes unfavorable conditions of the surrounding environment. And fasting enables the preservation of mitochondrial functions, which deteriorate as we age. This is a key indicator. Nevertheless, despite the existence of shared characteristics, if you desire to accomplish these three objectives, you have the flexibility to select any diet that is suitable for you, or time-limited feeding, or intermittent fasting, or a dietary approach that mimics the effects of fasting. However, there is also its own specificity. Here is the time-restricted feeding, which is loved and cherished by all of us, has its own unique and distinctive feature that sets it apart. This is the synchronization of our biorhythms. What are biorhythms? Well, you can imagine that different hormones are released in our body at specific times of day and night. Melatonin is released at night. At night, towards morning, cortisol is released. In the morning, we have higher prolactin levels, testosterone levels, and so on. And in accordance with this, all of these changes, the fluctuations of hormones, our peripheral rhythms make adjustments too. Adipose tissue, heart, liver, muscles, and all other organs demonstrate unique behaviors and functions within the complex system of our body. And this diet, which is only available for a limited time, is what synchronizes our biorhythms. Well, let me explain with a simple example. Suppose you have a ketogenic diet and intermittent fasting. What occurs in this instance? We all comprehend that initially lipases are triggered, hormone-dependent lipases, such as growth hormone or adrenaline, norepinephrine, encompass fat breakdown. The fat is divided into 3 glycerides and fatty acids. These 3 glycerides undergo gluconeogenesis, a process that takes place in the liver. In other words, glucose is synthesized from the 3 glycerides, and accordingly, the liver enzymes responsible for glucose synthesis must work precisely during the breakdown of fat in order to ensure proper metabolic functioning. And when does it happen? Then when we need energy, that is during the day, for example, during physical work. Fatty acids from fats must also be split in the mitochondria, where they are oxidized. Accordingly, the enzymes of the mitochondria that oxidize fatty acids must also work actively when we need it. Subsequently, acetyl-CoA is generated in large quantities from fatty acids during a ketogenic diet, and as a result, it is imperative to synthesize ketone bodies from this surplus acetyl-CoA. Acetic acid and beta-hydroxybutyric acid, which is synthesized in the liver, and then it should be distributed to the muscles. Enzymes must also be involved in the muscles, converting beta-hydroxymasic acid into acetyl coenzyme A through a biochemical process. And once more, it will commence functioning in the mitochondria and energy will be produced. Here is how I desire to illustrate that all of these enzymes, which take part in thousands of different biochemical reactions, must operate in synchronization. And the same applies to insulin sensitivity and so forth. This is where time-restricted nutrition greatly assists us. It synchronizes all of our processes. This is its unique characteristic. However, there is also its peculiarity, which is shared in conjunction with the current interval fasting of 2.5. Firstly, one of its key abilities is the capacity to convert white fat into brown fat. Yes, we have brown fat, which is beneficial, and brown fat participates in thermogenesis, that is, in heating the body, and accordingly, thanks to this, we do not freeze. And despite the fact that it exists in tiny amounts, research still shows that time-restricted feeding and intermittent fasting. Here they have a common feature, the ability to convert white fat into brown fat. These two types of hunger also possess the ability to enhance thermogenesis, that is, the generation of heat in our body. Moreover, these two forms of fasting effectively regulate appetite by impacting the secretion of glucagon like peptide 1, ghrelin, leptin, and peptide YY, thereby controlling hunger and satiety signals in the body. These components have an influence on our appetite and as a result lead to a decrease in our appetite. And here I am already transitioning to intermittent fasting, discussing the overall characteristics of time-restricted eating. Intermittent fasting also possesses its own unique attributes. The first unique attribute is neurogenesis, which is the ability to generate nerve cells, even in small quantities. For instance, this is an extremely valuable property after a stroke or any neurological injuries that may have occurred. The subsequent characteristic involves the synthesis of regulatory RNA, which is ribonucleic acid that generally encodes specific proteins. However, there exist distinct types of non-coding RNA that our cells employ to activate or deactivate specific genes, playing a crucial role in gene regulation and cellular processes. What does it mean to turn on or off the gene? If we turn on a certain gene, it starts producing a certain protein or enzyme or some other structural unit. If we switch it off, then correspondingly, this gene does not perform any function. And it is these non-coding RNAs, also known as microRNAs, that are highly regulated by intermittent fasting. And of course, we need this in order for the body to rebuild during intermittent fasting, the activation of certain genes. The third characteristic is distinctive. It has the ability to stimulate hematopoietic stem cells. The fact of the matter is, hematopoietic stem cells are cells that are situated in our bone marrow, which provide us with buds from which erythrocytes, leukocytes, neutrophils, monocytes, and so on are derived and play crucial roles in our immune system and blood production. Therefore, all of these cells possess buds known as hematopoietic stem cells in their structure and function. Starting from this location, we have immune cells, platelets, and consequently, the stimulation of hematopoietic stem cells is extremely advantageous for individuals who are already in advanced age and have a diminished function of the bone marrow. And the fourth distinct factor is the regeneration of axons, which are the long projections of nerve cells. Axons are extensions of nerve cells through which electrical impulses are transmitted. For instance, This feature is extremely helpful in cases where there is any damage to the nerves. To restore sensitivity or conductivity, motor impulse is needed to regenerate axons in order for them to be functional again. And we handle this by implementing intermittent fasting? Well, obviously not to the extent that nerves regenerate right away, but at least such capability has been demonstrated in various research studies. To conclude, intermittent fasting shares 3 more common features with a diet that mimics fasting in addition to the aforementioned similarities. The initial characteristic is the stimulation of the functions of beta cells of the pancreas and even their regeneration. Beta cells, as you may know, are responsible for producing insulin in our pancreas. Consequently, this process is of utmost importance for individuals with diabetes, including those with type 2 diabetes, as their beta cells gradually lose their functionality. It is also crucial for individuals with chronic pancreatitis, where beta cells are already being replaced by connective tissue, and for individuals experiencing glucose spikes in general. The subsequent common feature they possess is naturally the presence of immunity against cancer. Yes, there is an existing anti-cancer immunity. The fact is, cancer cells are actually perceived by our immune system as something foreign entities. Indeed, a certain subset of cells manage to successfully provide immunity against cancer for us. Specifically, they play an effector role, that is, a role in destroying tumors. This role is mainly carried out by effector lymphocytes, which are known as CD8+ cells. And these CD8+ T lymphocytes are effectively activated and undergo rapid multiplication and expansion during intermittent fasting and in response to a diet that mimics the effects of intermittent fasting. And ultimately, the third common factor is the stimulation of stem cells located in the intestine. Cells in the intestine continuously die, new ones continuously appear, there is a continuous turnover. And if this process is interrupted, the intestines start to experience difficulties. In order to ensure a continuous regeneration of cells, we might require intermittent fasting or a hunger-mimicking diet. Ultimately, a diet that emulates fasting has only 2 distinct differences, making it stand out from other approaches. The first difference is the differentiation of nervous tissue. After our nerves have multiplied, nerve cells, or rather, they need to differentiate into one or another tissue to perform a variety of nervous tissue in order to perform their function. Here, nerve differentiation is enhanced precisely by a diet that imitates fasting. Another crucial property is the stimulation of cells that develop into oligodendrocytes, playing a vital role in the formation of myelin sheaths around nerve fibers. Oligodendrocytes are cells found in the central nervous system, such as the brain, responsible for producing myelin, a protective substance. This is a substance that surrounds axons, that is, the extensions of nerve cells. And accordingly, it can be compared to wire insulation. If our wire is insulated, current flows through it without any interference. In the event that the myelin sheath of nerve cells is destroyed, they are no longer able to function properly. And here is a prime example where the demyelinating disease in question is multiple sclerosis. Simultaneously, it is the myelin sheath that experiences damage in individuals. Hence, we can infer that such a diet, resembling fasting, can occasionally provide advantages for individuals with multiple sclerosis. Thanks to these properties of different types of intermittent fasting, they are currently being utilized quite effectively in 4 different areas. The initial region is naturally metabolic health. The highest point of metabolic unhealthiness is metabolic syndrome. That is abdominal obesity, it is visceral obesity, when there is an accumulation of fatty hepatosis, fat between the loops of the intestine and pancreas can be observed and identified. And so on. This is insulin resistance or type 2 diabetes, this is of course hypertension, and this is dyslipidemia, that is an increase in low-density lipoproteins, which are commonly known as bad cholesterol. And all varieties of intermittent fasting are effective in combating this particular issue. Firstly, because it is an effective method to create an energy deficit, which refers to the situation when an individual consumes a lower amount of food, leading to weight loss and subsequently reducing insulin levels, decreasing insulin resistance, enhancing sensitivity, lowering the levels of insulin-like growth factor 1, and normalizing the levels of hormones such as leptin, adiponectin, ghrelin, and others. And also the immune system, sleep, nervous system, and so on. So here the benefits are undeniable for all forms of intermittent fasting, and you can definitely select the one that is suitable for you. The second area of application is cancer treatment. This is where the majority of the research is focused, with numerous studies already conducted on significant populations. The majority of these studies revolve around diets that mimic the effects of fasting. As an illustration, in a particular study, there were a total of 129 women who were diagnosed with stage 2 or 3 breast cancer. These women had a HER2-negative phenotype, which is a more favorable type of breast cancer in comparison to other subtypes. And there were very good outcomes achieved. Chemotherapy in combination with a fasting-mimicking diet was administered to a specific group of individuals, whereas the remaining group solely underwent chemotherapy without any dietary intervention. Naturally, this was a study conducted with randomization, indicating that individuals were selected in a random manner, and it was found that after a period of chemotherapy, in those individuals who received chemotherapy alone without any dietary modifications, approximately 40–50% of cancer cells remained present in the biopsy samples that were taken for analysis. And those individuals who received both dietary intervention and chemotherapy experienced a nearly 90–100% eradication of cancer cells. And, incidentally, all of the patients tolerated this diet, which simulates fasting very well. Additionally, there were other studies conducted on different types of cancer, and more frequently, of course, there was data available on breast cancer. However, I have examined registered studies that specifically investigate the combination of chemotherapy and the utilization of a diet that mimics fasting in order to determine its potential benefits. In my opinion, I am considering making a separate video specifically about intermittent fasting and fasting in general, as well as exploring the mechanisms that contribute to the healing or improvement of symptoms in individuals with cancer. And while I am still continuing, by what mechanism can relief work be implemented to support patients suffering from cancer? Firstly, as you are aware, there exists the Warburg effect in cells that are affected by cancer. The Warburg effect was first described in the 1920s by Otto Warburg. It is characterized by the phenomenon where cancer cells actively utilize glucose and simultaneously break it down in the presence of oxygen. This is nonsensical. This is a paradox, because normal healthy cells split glucose without oxygen only in situations when there is an absence of oxygen. This process is known as glycolysis. Well, glycolysis is also the initial step of it is referred to as aerobic oxidation, oxidative phosphorylation, when glucose is fully broken down into carbon dioxide and water, and a substantial quantity of adenosine triphosphate is produced. However, the initial step is glycolysis, which rapidly takes place in our muscles and in fact only under conditions of oxygen deprivation or when there is a shortage of oxygen. In a cancerous tumor, there is an excess of oxygen in the body, but glycolysis still takes place with enhanced speed characteristics, despite the presence of an ample amount of oxygen in abundance. This is called the Warburg effect. The thing is, during glycolysis, we accumulate pyruvic acid and then lactic acid. And this lactic acid creates local acidosis, that is, acidification, tumors, and also lactic acid is then excreted into the body, and naturally the body has to use various buffer systems to neutralize this acidity, and it has to breathe more often to exhale carbon dioxide, which is formed as a result of increased acidity in the blood. The kidneys are strained and so on. In addition, in the case of cancer, The body also requires the synthesis of glucose from lactic acid, as otherwise it would not be able to eliminate lactic acid from the system. So the body expends a significant amount of energy on this, and as a result, in an individual with cancer, cachexia can intensify, that is, lead to extreme exhaustion, because the body utilizes a substantial amount of glucose to feed cancer cells and support their growth and proliferation. They utilize this glucose inefficiently, produce lactic acid, which also needs to be neutralized and converted back into glucose. So, in case we commence fasting, even intermittent fasting, since I reiterate once more, total fasting is an unwise concept for individuals with cancer. It is crucial to discuss this with the attending physician, all the advantages and disadvantages, and the methods of conducting such therapy. I do it in my office in the clinic. Hence, intermittent fasting leads to the body being deprived of glucose, which happens naturally and is a result of the fasting process. A person doesn't eat anything, he gets little glucose. As a result, the processes of glycolysis slow down. Why? Because one of the moments insulin decreases due to the absence of glucose, eliminating the need for insulin. And the antagonist of insulin is glucagon. And the thing is, insulin stimulates glycolysis, i.e., when you consume something sweet, in case there is a cancerous tumor, God forbid, then you also raise insulin levels, thereby stimulating glycolysis and triggering the Warburg effect. If you skip taking insulin, if you refrain from consuming sweets, and your body initiates the production of glucagon in order to convert tissues, remember I was discussing gluconeogenesis, which is the process of forming glucose from lactate, lactic acid, and amino acids, as well as from triglycerides, thereby activating glucagon. And it decelerates the processes of glycolysis. Consequently, it shuts down the Warburg effect. When the Warburg effect is deactivated, the tumor, which is cancerous, loses its source of nutrition and becomes more susceptible to the effects of drugs used in chemotherapy. Additionally, as previously mentioned, it occurs during a diet that mimics starvation, and during intermittent fasting, there is activation of anti-tumor immunity. This means that active CD8 plus T lymphocyte cells start actively destroying the tumor, including their own immune forces and mechanisms of defense against cancer cells, thus enhancing the body's ability to fight against cancer. You know, there are already medications that can cure some cancers, such as rectal cancer, with a 100% success rate. I had a video about the medication that caused it. The 4th stage has been successfully treated. And this medication, through its mechanism of action, exhibited the activation of its own immune response. These CD8 plus T cells are responsible because they blocked PD-1. The important point is that T lymphocytes have a molecule called PD-1, which plays a crucial role in immune regulation. This is a molecule that acts as a checkpoint, and when it interacts with a specific molecule on a cancer cell, it turns off the lymphocyte. The lymphocyte simply does not attack it. Therefore, if you inhibit this PD-1 receptor, CD8 plus T lymphocyte begins to exhibit aggressiveness towards the cancerous tumor and gradually consumes it. And in accordance with this, we have intermittent fasting and consequently a diet that simulates fasting, which also activates CD8 plus lymphocytes. I am not implying that it could potentially be PD-1 receptor blockade. I do not possess any information regarding it, but in some way or another this activation still takes place and it is beneficial. Once again, it significantly impacts the treatment of cancer. Furthermore, the sensitivity of tumors to chemotherapy agents is enhanced through intermittent fasting and a diet that mimics fasting, leading to improved outcomes in treatment. And ultimately, a reduced number of side effects, that is to say, the DNA of healthy cells has a better recovery. The truth is that chemotherapy agents regrettably cause harm not only to the DNA or other vital organelles of cancer cells, but also to healthy cells in the body. However, they behave in precisely the identical manner on healthy cells. Only healthy cells are more or less in a state of rest, and chemotherapy medications for cancer are intended to impact actively dividing cells. That is the reason why the intestines suffer, the bone marrow suffers, and hair falls out during the use of chemotherapy drugs. In this context, Intermittent fasting and a diet that simulates fasting play a crucial role in assisting to protect our body from the harmful side effects of chemotherapy treatment. And ultimately, the subsequent, relatively well-investigated domain we possess is anti-aging, that is, the battle against the natural process of aging. As you are aware from my videos, one of the main mechanisms of aging is the constant activity of the intracellular complex known as mammalian target of rapamycin-1, mTOR1. This is the primary regulator that controls anabolism, which is a crucial process in our body. He simply inhibits autophagy, he stimulates cells to reproduce, to various anabolic processes, to protein synthesis, and other similar mechanisms. But this also leads to doing a bad service to us, because under the influence of the mTOR1 complex, errors in DNA accumulate in us, autophagy slows down. As I already said, various tumors occur more often, changes occur more often in cells, which in fact lead to aging. That is the reason why rapamycin is regarded as one of the most promising methods of combating aging at present. Research is currently being carried out on it because it blocks the mTOR1 complex, and it has already been successfully demonstrated on mice that mice have a longer lifespan. Individuals who own dogs apply to people who own large animals and have a desire for their dogs to live longer and avoid death. Well, finally, a lot of people are already using rapamycin at their own peril and risk. There are even whole communities. I do not recommend embarking on this yet, although numerous people, I reiterate, utilize it. Why is that? Because there are ongoing clinical trials that will provide us with a comprehensive understanding of the effectiveness of tropomycin, including optimal dosage and its applicability in treating aging-related conditions. Considering aging as a disease, intermittent fasting, time-restricted feeding, and a diet that mimics fasting all have an effect on both mitochondria and gut microbiota, leading to improved metabolism and enhanced nerve regeneration, thereby highlighting their potential in addressing the challenges of aging. So these are all the processes that we experience as we age. Therefore, this technique is highly effective and completely safe. You can make your own choices in order to slow down the aging process or at least age gracefully and beautifully. And ultimately, the fourth region, which additionally has a great deal of promising research. This is a fight against neurodegenerative diseases. First of all, it is Parkinson's disease, Alzheimer's disease. These are serious illnesses that are also characterized by the buildup of specific substances in nerve cells that hinder their movement and affect their ability to function properly. And consequently, they hold the belief that the activation of autophagy and neurogenesis, along with the various differentiations of nerves that occur during intermittent fasting, lead to the deceleration, at the very least, of neurodegenerative processes that develop in such diseases. In this manner, we comprehend how to utilize different techniques of intermittent fasting and how to assist ourselves in accomplishing the objectives that you establish.